Hi guys, very good evening. Welcome to the session. Myself Dinesh Gutha. So today's topic is about one second. Stop. Hi guys, very good evening. Welcome to the session. Myself Dinesh. So today's topic is entropy, mutual entropy, conditional entropy on a binary symmetric channel. So the agenda of today's session is, so before talking about the agenda of today's session and then continuing with the session, let me introduce myself. So I'm having 10 plus years of experience. I've done my masters from IIT Madras. These are my subjects of expertise and this is my Telegram group. So if you wish to ask me any doubts, you can follow me on this group. Right. So what is the agenda of today's session? So we'll talk about information theory and entropy. So we'll talk about briefly about information theory. So because entropy is based on finding about information from a source. So we'll talk about how to find information from a source, and then we'll talk about entropy. And once we talk about entropy, we'll talk about joint entropy, conditional entropy and mutual entropy for a binary symmetric channel. So in the last 2 days or last 2 sessions, we've talked about binary symmetric channel. So based on binary symmetric channel, we have covered wonderful questions in yesterday's session. But in today's session, we'll cover some other models of questions that are possible from binary symmetric channel, and those questions are based on these entropies. Okay. So since I want to cover all the models of problems possible in binary symmetric channel, I'm giving you some basics of entropy, and then I'll be talking about these entropies based on binary symmetric channel. Right. After that, I'll give you some homework questions as well. So before starting the session, I'll first discuss whatever I have given you one homework question in yesterday's session. First, let me talk about it. Right. So this is the homework question. Right. So this is the homework question I have given. Let us quickly solve it. So they have not plotted the channel, but from the given information, we can plot the channel ourselves. So what they are saying, the transition probability as 0.9. So take this as 0.9, which means this will be 0.1 because it is a symmetric channel. Because it is a symmetric channel, if this is 0.9, this also will be 0.9. So if this is 0.9, this will be 0.1. One information is sufficient for a binary symmetric channel. All the three other informations we can easily find out. Right. So for 0, they have given the probability. Let me say this is x0 and x1. This is y0 and y1. So it is given that p of x0 probability or 0 probability is 0.4, which means p of x1 probability we can find it as 0.6 because addition of these two probabilities should result in 1. Right. Same procedure. Procedure is, as I told you, to find everything that is possible from this problem. One thing that we have to do is, first thing that we have to do is find the intersection probabilities of each line. So for this line, okay, right. Now, so among these two lines ending at y0, let us make a decision based on y0. So decision making is not being asked in the question, but let us find it. There is nothing wrong in finding it out. So y0 implies, so for y0, more probabilities because of x0. So that's why more probability y0 we are getting because of x0 with a probability of 0.36, and the same y0 we are getting it because of x1 with a probability of 0.06. So the best decision to make is, when you see y0, make the decision as x0. You will be correct with a probability of 0.36, and you will be wrong with a probability of 0.06. So may I mark this as correct line and this is the wrong line. So when you decide like this, you are wrong 0.06 with a probability of 0.06. So which means with this probability you are going to be wrong, which means this will contribute to the probability of error. Next. So by looking at y1, let's make a decision, and the decision is y1 we are getting because of x1 with a probability of 0.54. y1 we are getting because of x0 with a probability of 0.04. Right? We are getting y1 with high probability of 0.54 because of x1. So what is the best decision to make? If the decision is x1, whenever you see y1, if the decision is x1, you are correct with a probability of 0.54 and you are wrong with a probability of 0.04. So do we want to be correct with a probability of 0.54 or not? Right? So this is the correct line and this is wrong line. If you make the other decision, then you will be correct only this much of time and you will be wrong this much of time. So the best decision to make is this. So the decision criteria is when you see y0, decide it as x0, and when you see y1, decide it as x1. Now we are being asked to find probability of error. So when we are asked to find probability of error, we have observed in the previous discussion, y1, you are always deciding it as x1. So when you receive y1 because of x0, and that happens with the probability of 0.04, then we are making a wrong decision. y1 we might be receiving because of x0 also, sometimes with the probability of 0.04. When that happens, we get an error because you are deciding it as x1. Okay, so we are wrong with 0.04 times or with a probability of 0.04. And here, when you are making a decision y0, you are making an error with a probability of 0.06. Overall, y0 and y1 together, we are making a error of 0.06 plus 0.04 which is equal to 0.1. That is the answer. And Sovadeep, I don't remember the name of the student, but one of the student has answered it perfectly in the comment section. Yes, Sanjay, it's 0.1. You have written it as 1.0 by mistake. Yeah, I can understand that you have done it correctly. So this is the answer for the homework question. Right. So let us start with today's topic. The topic is information theory and entropy. First, let us understand how to find information. What is information? How to find information? And then we'll talk about average information, which is what we call as entropy. And then we build on to mutual entropy, conditional entropy, and joint entropy. Okay, right. So how to measure information from a source? For example, there is a source. What do I mean by source? Anything which generates information, like keyboard. When you type, you are generating information. Okay, I'm speaking a voice signal. I'm also a source. Anything which generates some information, we can call it as a source. So just for the easiness of understanding, let us talk about a discrete source. Example of discrete sources: keyboard is a discrete source. There are many discrete sources. And if you see analog to digital converter, quantizer is also a discrete source, right? There are hundreds and hundreds of sources we can talk about. So, but let's talk about a simple source. Let's say a source produces some symbols x0, x1, x2, and so on. Let's say these are the symbols, discrete symbols produced by the source. Now, because this is information, always information is linked to probability. If the information is deterministic, then we don't call it as information because there is nothing that we don't know about it. Because deterministic things don't have any value. Okay, so when there is something deterministic, we will not be interested in it, right? Because, for example, if you know the result already, you will not be excited about the result, right? If you know the result of a match, if you are watching a cricket match, and you will not be excited to see the match because if it is not a live match, right? Some people might be watching for some other reasons, the recorded matches, but generally we will not be excited because we know the information already, what happened at the end. At the end result, if you already know, there is no information new information that we are getting out of that match, right? So anything uncertain, anything probabilistic, that is what has information. Any source which produces information, producing information means it is always probabilistic or it is uncertain. Uncertain means probabilistic, right? It happens with a certain probability, right? So any information will have probabilities linked to it. So let's say x0 is having a probability of p of x0, and x1 is having a probability of p of x1, and x2 is having a probability of p of x2, and so on. All the symbols produced by the source, let's say they are having certain probabilities. Okay. Now, information, let us understand it in a commonsensical way, how information is linked to probability. If probability is high, is the information less or more? I will call information as how excited you are about it. How excited you are about a particular outcome. That is what I call as more information or less information. You are more excited means you can say, I would say more information in a layman language, if you want to say. For example, a match is happening between India and Scotland, or India and Bangladesh, let's say. Bangladesh has become a little stronger now, but let's say India and a weaker team, okay? So if a match is happening between India and Bangladesh, we know with a probability of 90% or 0.9, India will win, and with a probability of 0.1 or 10%, Bangladesh will win, okay? So today night match is happening, and you forgot for some reason, because of busyness, you did not watch the match, but you are excited to know the result, okay? Tomorrow in newspaper you are trying to see what happened, what is the end result, and if India has won, you'll be happy because it's our country. We'll be happy, but not very excited because we know the result already. Because 0.9 probability India will win, which means we almost know that, it's almost certain, but not exactly certain. Almost it's decided that India will win. But with a less probability, Bangladesh has a less probability of winning. But if in the news, in the morning, if you are seeing that Bangladesh has won, then you'll be sad, but you'll be excited about what happened. You'll be trying to scold each and everyone, right? Who has not played well in the match. You'll try to scold each and everyone in the team. You'll scold the captain. You'll scold the bowlers, batsmen, everyone. You'll try to scold because there is a lot of information in it. Because it happens very rarely, you are gonna behave in a different manner, right? So anything which happens very rarely, you can think of it as a lot of information. Okay, for example, a tsunami happens. It happens once in a while. If somebody says that tsunami has happened, it's like a rare information. Anything rare is like huge information. Okay, right. So information is always inversely proportional to probability. This is not an exact sense, but in a rough sense, in a commonsensical manner, if you want to understand, information and probability are inversely related. Because if probability is more, you're having less information, because we almost know the end results. Most of the time, we know the end result. Right. So how exactly do we measure it? Not exactly inverse relation, but not exactly in a linear inverse relation. So information, I'll denote it with I. Let's say, for example, I want to find the information in a symbol x0. Information in x0. I means information in a symbol x0. How do we find that? By using logarithm. Logarithm of 1 by probability. Using probability, we find information. See this one? And what is the base? Base can be anything. Base can be anything. So if, for example, if the base is 2, we measure the information in terms of bits. Similarly, base can be others also. The general bases that we use, any base can be used basically, but the general bases that we use are E, 10 and 2. If you are using the base as E, then the measurement of information, the information that we calculate, should be measured in nats. And if you're taking the base as 10, since it is decimal base, we call it as decits. We call it as decits. We call it as decits. Right. So out of which we prefer this one. We prefer measuring information in terms of bits. Okay. There is nothing wrong in measuring in nats or decits. Any base is fine. Any of these three bases is fine, but we prefer base 2. We are convenient with that. We are having comfort in that. Right. So I hope you have understood how to measure information. If you want to measure information, what should you have? We should have probability. If you want to measure information in a particular symbol, we should have probability of, we should know the probability of that symbol. Just inverse the probability and apply logarithm. You'll get the information in a particular symbol. Similarly, you can find the information in other symbols also. Whatever symbol you want to find the information, take the probability of that symbol, inverse it, and apply logarithm. As simple as that. Okay. So till now, what we have talked about is information in a particular symbol, not in all symbols, right? So we have talked about information in a particular symbol. So how about information of a source? We are talking about number of symbols are produced by the source. We are talking about how to measure information in a particular symbol. How to measure the information from a source. Source produces a lot of symbols. When you talk about information source, you have to talk about average information of all the symbols together. Average information of all the symbols together, right? Right. So how do we average? How do we average? Okay. Can you confirm? Yeah. Okay. Right. So using that basic, let us talk about average information from a source. So we have talked about information in a particular symbol. Okay. We have talked about information in a particular symbol. Using this basic, we can find information in all symbols. So first symbol, the information in the first symbol is logarithm of 1 by p of x naught, and information in the second symbol is logarithm of 1 by p of x2. Similarly, in the third symbol, logarithm of 1 by p of x3, and so on. Like that, how many symbols are there? Or for all symbols, take the information in those symbols. What do we want to average? We want average information. So I have taken the information in all symbols possible. How many symbols are there? I have found the information in all the symbols. Now what do we want? We want the average of all of them. We want the average. How do we find the average? Whatever you want to average, take all the possibilities in that. Whatever entity you want to average, take all the possibilities in that. For example, I want to average the information in the source. Whatever informations are possible, so many symbols are possible, find the informations possible in those symbols, and try to average them. How to average them? Take all the possible informations and just multiply them with corresponding probabilities and then just add them up. So this information, with what probability does that happen? It happens with the probability of p of x naught, and this information happens with the probability of p of x1, x2, and this information happens with the probability of p of x2, and so on. As simple as that. So finally, we can simply write it as sigma p of xi into logarithm of 1 by p of xi, where I runs from 0 to, if there are infinite symbols, you can write it as infinity. If there are 10 symbols, you can write it as 0 to 9. Okay, right. So what does this give you? This gives us entropy or average information, which we denote it with H. Average information. We have found average information from any source. From any discrete source, you can find the average information using this formula. And this formula is not a big deal. You don't need to remember it. We got it from the very basics. So H is the notation for entropy or average information. Average information, we also call it as entropy. When somebody says entropy, you have to understand that they're talking about average information. So like this, we can find information in any source. Okay, I hope it is clear till this point. Right. Now, what if, let's say x is a random variable and it takes some values x0, x1, x2, and so on. If you're talking about random variable, all the possibilities of random variable will have probabilities. The same discussion as previous case, just I'm using the word random variable here. Whatever is produced by a source, the output of a source can be modeled as a random variable also, right? So if you have taken the notation as x, the outcome of our source, if I'm defining it as a random variable and I'm denoting it as x, instead of h, we can use the notation as h of x also. H is the notation that we use for entropy. If you're talking about the entropy of a random variable, it can be discrete random variable or continuous random variable. If you're talking about entropy of a random variable, because random variable also has some possibilities which we can think of as symbols also. Symbol is just a word. We use it in multiple situations in communication. Okay, right. So the possibilities of random variable, you can think of like symbols in the previous slide discussion. You can think of them as symbols. The possibilities of random variable, all the possibilities of random variable will have probabilities. So every possibility has some information. We can find that information, and you can find the average information of all the possibilities of random variable. So if you're talking about random variables entropy, you can denote it as h of x. If you're talking about random variable y's entropy, you can write it as h of y. So what is the formula for this? We've just now found it. It is sigma p of xi into logarithm of same formula whatever I have written previously. I'm just copying it, where I runs from 0 to, you can, if there are infinite symbols, let it write it as infinity. Okay, right, as simple as that. If you're talking about y, yes, p of y into logarithm of 1 by p of y, yi. Very simple stuff, right? So that is the understanding of average information or entropy of a random variable or of a source. How about this is the case of x being discrete. Okay, this is the case of x being discrete, and the probabilities are p of x naught, p of x1, and so on. What if x is continuous? Yes, we can talk about information of a continuous source also, or a continuous random variable also, right? So h of x, where x is continuous. If x is continuous, then also we can do the same stuff. If x is continuous, what happens? Since it is not a discrete variable, summation is not valid. We have to use integration. Instead of p of xi, we have to use PDF. Yes, this is also PDF only. PDF, because but we do use continuous PDF. Continuous PDF general, we denote it as f of x or fx of x into logarithm of, instead of p of xi, we will write the continuous probability density function. A simple difference. Funda is same. This is how we find the information. Logarithm of 1 by probability will give you information. Multiply with the probability and just add it up. That will give you average. Because for continuous case, we can't add it up. So we have to do integration. Limits from minus infinity to plus infinity. Okay. X is a random variable, means a random variable. Continuous random variable takes all the values from minus infinity to plus infinity. So we can write the limits as minus infinity to plus infinity. Right, for a continuous random variable and discrete random variable, a slight difference, but the idea behind it is very simple, which we have understood in the previous slide. I hope it is clear till this point. Is it okay? Okay then, let's talk about maximum entropy. Very important stuff. To understand maximum entropy, what I'll do is I'll talk about a very basic case. I'll talk about source with two symbols. Source which takes only two symbols, x naught and x1. Two symbol source. I'm talking about two symbol source. For a two symbol source, now symbols can be A, B, or anything. You can write the name of symbols as anything. So what I'm taking as two symbol source. If there are two symbols, if you add the probabilities of these two symbols, the result should be 1. So let me assume the probability of the first symbol is p and the probability of next symbol is 1 minus p. Just for convenience, I am assuming the probabilities as p and 1 minus p. If you want, you can write as p of x naught. If you want, you can write as p of x1 also probabilities. But just for convenience of writing, I'm writing the probabilities of first symbol as p and the other one is 1 minus p. Because summation should be 1, there is no need of assuming it as p and q, because we know the summation should be 1. If I assume 1 as p, another one should be definitely 1 minus p. Right. So what is the information in this one? Logarithm of 1 by p. What is the information in this one? Logarithm of 1 by 1 minus p. This is the information in this, this is the information in this. Let's average. How do we average? This happens with the probability of p and this happens with the probability of 1 minus p. Just multiply with the probabilities and just add it up. That will give us the entropy. Yes, we got the entropy. Now, what do we want to find? We want to understand when does entropy become maximum. We want to understand when does entropy become maximum. So, if you want to find the maximum of a function, so see this one, this entropy is dependent on the variable p. As p changes, this h also will change. So, h is dependent on p. So, we can think of h as a function of p. Okay, h is definitely a function of probabilities. So, let us differentiate h with p, because we want to find maximum. How do we find maximum? We differentiate and equate it to 0, and that is how we find the maximum. Right? We want to find the maxima. Yeah, we're differentiating. Let's differentiate. So it is p into differentiation of this. Yeah. So if you want, you can write this as okay. You can write this as minus p log p minus of 1 minus p log 1 minus p. I'm just writing 1 by p as minus log p and 1 by 1 minus p as minus log of 1 minus p, like that. So now let us differentiate. So p uv rule, I'm just applying uv rule, uv dash logarithm of minus outside, logarithm of p differentiation is 1 by p. Okay, next plus uv dash is done, u dash v, p differentiation is 1, and logarithm of 1 by p, logarithm of 1 by p is log p, that minus as it is because we have taken that minus outside, we are differentiating that. Okay. Okay, next one, differentiation of the next one is minus 1 minus p into logarithm of 1 minus p differentiation is 1 by 1 minus p, and differentiation of 1 minus p is minus 1. This total thing should become 0. 1 minus p cancel, p and p cancel, and if you observe, this is minus 1 into minus is plus, and this is minus, this is minus 1 and this is plus 1, right? I think yeah, we missed something. Yes, we missed the next part. So we have done uv dash, but u dash we have to do. U dash is minus 1, differentiation of 1 minus p is minus 1 into logarithm of 1 minus p. So this total thing is cancelled because this is plus 1 and this is minus 1. Now this implies this is minus log p, and that is plus log of 1 minus p. This is equal to 0. Log of 1 minus p outside, this log of 1 minus p I am putting this side, and I am sending this minus log p onto the other side, and it implies 1 minus p is equal to p, and this implies p should be equal to half. So we can do some conclusions here. What is the result that we got? For a two symbol source, entropy or information or average information is maximum. Definitely we know that entropy is dependent on probabilities, how the probabilities are distributed, or entropy is dependent on PDF, you can say. So entropy is maximum when the probabilities of both the symbols are equal. Can we extend it to many symbols case? We can extend it to any number of symbols. Any number of symbols. If any number of symbols from a source, if all the symbols are having equal probability, we can say that entropy is maximum. Okay, we have just taken a two symbol case for the ease of mathematics, for the ease of calculations. For higher symbols also we can prove, but it will be little complicated mathematics. So we can extend the same result for higher order symbols also. Any number of symbols from a source, entropy will be maximum if all the symbols are equally likely. Okay, so we can draw a graph also for this, because this graph is seen many times in previous year papers also. Because h is a function of p, let us plot p and h of p. Because h is a function of p, I am writing it as, instead of just h, we can write it as h of p. If you plot it, this function, we know it is maximum at half, and we know it is some kind of non-linear function, and at p equal to 0, see this one, at p equal to 0, this becomes 0, and this also becomes 0, because when p equal to 0 it is log 1, which is 0, the total thing becomes 0. When p equal to 1, this becomes 0, and this also becomes 0. For p equal to 1 and p equal to 0, it becomes 0. We know the value at p equal to 0, and at p equal to 1, we know it is 0. At p equal to 0, it is 0. At p equal to 1 also it is 0. Substitute in this function and see, you will get it. And we know that at p equal to half, it is maximum. And we know at p equal to half, it is maximum. How much is it? We will figure out. And we know that it is a non-linear function. It's not a linear function. It's not a straight line, definitely. It is some kind of non-linear curve. So it might be something like this. We know we are having a maximum at half. It is something like this. We are having a maximum at half, at p equal to half, right? So how much is that that value, that entropy, the maximum entropy possible when it happens when p equal to half? You can substitute p equal to half and find the result also. So h is equal to h of p equal to half is equal to, you can substitute here and see, base is 2 here, base is 2. So logarithm of, in this, if you substitute p equal to half means it is log 2 to the base 2, which is p is also half, it is half, plus this, if you substitute p equal to half, this becomes log 2 to the base 2, which is 1 minus half is half, it becomes 1. So the maximum value possible here is 1, the maximum entropy is 1 for a two symbol source. for a 2 symbol source. Shall we extend it for multiple symbols? Let's extend it for multiple symbols. We can generate some generalized result. We can get some general result. Yeah, let me write it here because we are having space here. Entropy from a source, or entropy of a random variable also you can call. Entropy of a source is maximum if all symbols are equally likely. And one more point is also there, and max entropy is, that is a very simple formula to remember. Max entropy is, what is that? Let's derive it and we'll write it there. If a source produces n symbols, let's say, if a source produces n symbols with equal probability, with all of the symbols with equal probability, this implies what is the probability of each symbol? What is the probability of x0 or x1 or probability of xi? Anyone? What is the probability of any symbol? See, because all symbols are having equal probability, no? All symbols are having equal probability and total probability should be 1. Okay, all symbols are having equal probability. Let me say probability of each symbol is p. Like that, n times you have to add p plus p plus p, like that n times. That should result in 1. So capital N p equal to 1, p should be equal to 1 by n. If n symbols are having equal probability, each symbol should have a probability of 1 by n. Then only if you add 1 by n plus 1 by n plus n times, it will result in 1. Right. Now let us find the entropy now. H of x is equal to sigma p of xi. I am just writing the formula first, into logarithm of 1 by p of xi, where I runs from 0 to n minus 1. Because we know there are n symbols. If nothing is mentioned, if there are infinite symbols, we can write from 0 to infinity. Because we clearly know that there are n symbols, it is given. So I'm writing it as 0 to n minus 1. Now let us substitute the things. I running from 0 to n minus 1, p of xi is p, the probability of each symbol for all symbols, for all values of I, the same probability, which is n 1 by n, into logarithm of 1 by n, it is equal to n to the base 2. Now this is equal to, see this one, for I equal to 0 we have this, for I equal to 1 also we have this, for I equal to 2 also we have this. So we are doing summation for different values of I, and how many times we are doing summation? We are doing addition of n different values, and each value is 1 by n times log n to the base 2. For I equal to 0 we have this, for I equal to 1 also we have this. Like this we are adding the same thing n times, capital N times, because there are because the summation runs for n different values. So total value is this n times of this, which will become log n to the base 2. I hope you have understood this part. For I equal to 0, this much, plus for I equal to 1, this much, for I equal to 2, again the same thing. So we are just adding this capital N times. So the result becomes log n to the base 2. Right. So finally the answer is logarithm of number of symbols. If a source produces symbols with equal probability, then just apply logarithm of number of symbols. Let me say number of symbols is n. Apply logarithm to the base 2. Okay. Fine. I hope it is clear till this point. Guys, like the video and subscribe if you have not subscribed already. And let's continue further. So we have understood maximum entropy, not just for 2 symbol source, but for all symbols. When we know when does maximum entropy happen, and we know how to calculate very easily what is the maximum entropy of a source or of random variable. Maximum entropy happens only if the probabilities are equally likely, if the probabilities are all equal. Right. So let us talk about joint entropy. Now we're going to talk about specifically about binary symmetric channel. We're going to talk about binary symmetric channel because we're talking joint entropy, mutual entropy, or conditional entropy. These three things are corresponding to binary channel only, not binary symmetric channel specifically, but binary channel. It need not be symmetric only. These things can be applicable to any binary channel. Right, so let me draw a binary channel first. So x0, x1, y0, y1. So joint entropy talks about joint probabilities. When you're talking about entropy, you're dealing with probabilities. You're dealing with symbols and their probabilities, right? So since you're talking about joint entropy, you're going to deal with joint probabilities. Whenever somebody uses the word joint, they're talking about intersection. End means intersection. When they're saying conditional entropy, that are going to talk about conditional entropies. I mean conditional probabilities. Conditional entropy deals with conditional probabilities. So now we are going to derive each and everything in a logical manner so that you'll not forget things. You don't need to remember things. You don't need to by heart. If you remember the concept, you'll get everything. Right. So let me fill the data here. So P of what is given here? P of y0 given x0 will be here. And what is given here? P of y1 given x1 will be here. P of y1 given x0 will be here. And P of y0 given x1 will be here. Right. Input. Let me call the input as x and the output as y. Both y0, y1 together, I'm calling it as y. The input x0, x1 together, I'm calling it as capital X. Now see this one. How to find the entropy of x, the input. There are probabilities for x0, right? P of x0 and P of x1 are the probabilities, right? How to find the entropy of the input? Very simple stuff. Very simple stuff. The input x is a random variable which takes values x0 and x1, or you can think of a source is producing x0 and x1. How do you find the entropy? It's very simple stuff. Whatever we have discussed in the previous slides, it's exactly the same. We are talking about entropy of one random variable, which is very, very simple, and that is sigma p of xi. Can I write it like this? Into logarithm of 1 by p of xi, where I runs from 0 to 1. For I equal to 0 and for I equal to 1, there will be two terms. Similarly, can we find for y also entropy of the output y? Because y is also a random variable, because y can take y0 or y1 with certain probabilities, right? So h of y, we can find same basic p of it's not, we're talking about y, right? So p of y0, it's not y0, we're talking about general thing, right? So we're talking about y0 and y1 together as a summation, yi logarithm of 1 by p of yi to the base 2, where I runs from, or you can say j also, anything is fine, 0 to 1. So this is the entropy of output y. Now let us talk about joint entropy, h of x comma y. This is what we call as joint entropy. Joint entropy, which deals with joint probabilities. Joint entropy, which deals with joint probabilities. How many joint probabilities are there? See this one. We get P of x0, y0. When somebody writes it as comma, comma means intersection. Okay. When somebody writes a comma between the symbols, it means they're talking about intersection probability. Comma or intersection, both are same. Here also there's a comma, which means intersection. You can say P of x0 intersection y0. How do we get this? By multiplying these two probabilities. P of y0 given x0 into P of x0. Similarly, earlier to solve all the problems, we used to find intersection probabilities of each line, right? The same way here also. Here for this line also we can find intersection probability, P of x1 intersection y0. For this line also we can find P of x0 intersection y1, and for this line also we can find P of x1 intersection y1. So there are 4 intersection probabilities or joint probabilities. When somebody says the word joint or intersection, they're talking about the same thing. So joint probability, joint entropy we want, which means we're talking about information in these joint probabilities. Whenever there is a probability, we can find the information by inversing the probability and applying logarithm. So can we find the information in this? Yes, very simple. Logarithm of 1 by p of x naught y naught, or x naught intersection y naught. When I say write comma, it's nothing but intersection. This is how we find the information in this. Next, how about the information in the next one? Next intersection probability, p of x1 intersection y naught. See this one? We found the information in this. Similarly, other two also, logarithm of 1 by p of x naught intersection y1, and last one is logarithm of 1 by p of x1 intersection y1. Right? So now we are having 4 probabilities, and corresponding to those 4 probabilities, we have found the information in them. Now what do we want? We want joint entropy. Joint entropy means average information. Joint average information. How do we average? We just multiply them with the corresponding probabilities. So this information happens with how much probability? This information happens with the probability of p of x naught, comma y naught, and this information happens with the probability of p of x1 intersection y naught, or intersection y naught is also okay, comma also is okay. Comma is more convenient to write, easy to write. Comma, let's write comma, let's write it uniformly. Comma means intersection, x1 comma y naught, and the probability with which this happens is p of x naught comma y1. The probability with which this happens is p of x1 comma y1. That's it. So let us simplify this. Let us write it in a more easy manner, in a simplified manner. Sigma, instead of writing 4 terms, let's write it as a single term by using summation. P of xi comma yj, instead of 1 0 1, I am writing it as I comma j, into logarithm of 1 by p of xi comma yj. Okay, where the summation is with a variable I runs from 0 to 1, but there is also one more variable which runs with respect to y. So one more summation also should be there, because there are 2 variables here. Summation, one more summation runs from j from 0 to 1. All these 4 terms, we are writing it as a single term by using those 2 summations. Okay, I runs from 0 to 1, j runs from 0 to 1. There are 2 possibilities here, 2 possibilities here, total 2 into 2, 4 possibilities. Wonderful. So that is the understanding of joint entropy. Very simple stuff. Just find the joint probabilities or intersection probabilities of all the lines, and just find the information in all of them and just average it up. Very simple. Right? In a binary symmetric channel, you can easily get the joint probabilities. Once you get the joint probabilities, inverse it and apply the logarithm to get the informations in them. Once you get the information in each individual line intersection, in each individual line, then you just average them with the same probabilities. Right. Now let us talk about conditional entropy. This is little tricky. You have to focus well. H of y, entropy in the output y, given x naught is transmitted. If x naught is transmitted, the possible outputs are y naught or y1. Okay, we have talked about h of y. When you talk about h of y, we are talking about y naught or y1. They are the 2 possibilities. Now given x naught also, the possibilities are y naught and y1. But since x naught is given, it is given x naught means the meaning of it is told that x naught is transmitted. When it is told that x naught is transmitted, what is the information? Okay, which means since a condition is given, we have to talk about conditional probabilities. So the conditional probabilities involved here are p of y naught given x naught, that is the conditional probability, and one more conditional probability is p of y1 given x naught. So how to find the information in this? Apply logarithm to this, 1 by inverse of probability, logarithm of inverse of probability, y naught given x naught. And how to find the average? Just multiply the corresponding probability. Similarly for this probability also find the information, logarithm of 1 by p of y1 given x naught. Find the information in the conditional probability. The conditional probabilities involved here are y naught given x naught, y1 given x naught. Those are the symbols. So for those symbols, find the information first and then average them by multiplying with the corresponding probabilities. Very simple. Which is equal to, in a simplistic manner, if you want to write, we can write as P of Yj given x naught into logarithm of 1 by P of Yj given x naught. Log to the base 2. Even if I missed writing log base also, you can understand that it should be base 2. In all this information calculation, we use only base 2 because we measure information in bits, where j runs from 0 to 1. Similarly, let us find information with respect to x1. If the condition is x1, information in y, when it is given that x1 is transmitted, same formula you can write sigma P of Yj given x1 into logarithm of 1 by P of Yj given x1 to the base 2. Okay, fine, where j runs from 0 to 1. So we got this. Now we want to find h of y given x. Now in this there are 4 cases: y naught given x naught, y naught given x1, y1 given x naught, y1 given x1. 4 cases. So how do we combine this? So we know h of y, information in y when x naught is transmitted, information in y when x1 is transmitted. We know these two. We have to calculate them. So if you average these two, information in y when given that x is transmitted, given that x means x naught can be transmitted or x1 can be transmitted. So let us divide it into 2 cases. We want to find information in y when x naught or x1, both of them is transmitted, right? So let us find the information in y when x naught is transmitted, and let us find the information in y when x1 is transmitted, and let us average both of them. And how, with what probability this happens? This happens with the probability of P of x naught, because the condition given is x naught. Under the given condition that x naught is transmitted, we are finding the entropy. So since x naught happens with the probability of P of x naught, this information also happens with the probability. This information also happens with the probability of P of x naught, and this information happens with the probability of P of x1 in the same manner. So let us simplify this. Sigma P of xi into, we know the stuff regarding this. What is it? It is sigma. So these two together we have written as P of xi, these two together, and okay, into P of yj, these two together, yj given xi into logarithm of 1 by P of yj given xi. So these two together. So if you substitute this here and this here and just combine all of them, then it will be looking something like this. So if you multiply these two, what will we get? P of xi into P of yj given xi. P of yj given xi. So if you multiply these two, you get intersection probability. Y given x into P of x. We get intersection probability. Right? So you get intersection probability. Just trying to finish it off in this step. P of xi comma yj or intersection yj double summation. Same thing whatever we have written previously, the same thing I am just writing here again, but by simplifying. I running from 0 to 1, j running from 0 to 1. Order of summation is anything, I or j, anything is fine. So see this one, there is a small difference. Joint entropy was much more easy to remember because whatever probability was here, same probability was here also in joint entropy. Whereas in conditional entropy, if it is y given x, the same y given x is there inside the logarithm, whereas outside whatever is being multiplied, that is not y given x, it is intersection probability or joint probability. We call intersection probability also as joint probability. Okay, so you have to mind this. Similarly, I hope you can write for x given y also. For x given y also you can write in the same manner. For x given y, it is exactly same here, and here it will be xi given yj. Xi given yj, slight difference. Okay, so we have talked about conditional entropy. So once a binary symmetric channel is given, you will be knowing all these probabilities. You just need to substitute them in this. Little bit of calculations are involved, so we have to use calculator. Definitely a calculator is required here. Right. So conditional entropy is done. So let's talk about mutual entropy. So I'll combine all of them and I'll simplify it. I'll simplify these things. Observe carefully. So how about mutual entropy? We denote mutual entropy with a symbol I, because H is already used. H of x comma y is already used for joint entropy. We use the symbol I of x colon y or comma y is also okay. So we call this as mutual entropy. There are 3 formulas for this. I'll tell you the meaning of all of them. So there are 3 formulas. I'll first write the formulas and I'll explain the meaning of them. H of x plus h of y minus h of x comma y. Add up the informations in x and y and subtract the joint entropy. Joint entropy means the joint information or the common information between these two. You're gonna remove it. It's like a plus b minus a intersection b, something like that. And one more formula is h of y minus h of y given x. Okay, and h of x minus h of x given y. In the previous slides, we have talked about formula to find this, find all of them. So using, you can find anything you can find easily, just find it up and apply one of these formulas to get the mutual entropy or mutual information. Okay, right. Let me explain a little bit about this using Venn diagrams. So this, you can think of it as h of x, information in x. You can think of this as x, and this total circle, it represents information in y. Okay. Now, mutual information means the common information between those two. Whatever is the information in x and y, the common information between those two, we can call it as mutual information. As the name says, mutual means common. Okay, right. And this part, apart from the common part, whatever is left in h of x, this we write it as h of x given y. The meaning, try to understand the meaning of this. Information in x, and only information in x means this total circle. Here it is information in x given that you know about y. If it is given that you know about y, you know some information about y. Okay, you means you know some information about. If it is given that y is, we know about y. Given means what? We know what has happened. It is given that y has happened. Given that you have seen the output, what is that unknown thing? Information means what you don't know, right? So if you know the output, if you are seeing the outputs, and you know some information that is common with the input, right? So if you are trying to find the information in the input, given that you know what has happened at the output, which means once you know the output, you know the information in the output, right? So what is the information that is there in the input after knowing the output? After knowing the output, you know this total information. After knowing the output, you know this total information. So what is the information in x? After you know that y has happened. Y has happened means all this information you already know. What is the information that is left in x after knowing y? Only this part, right? H of x given y means information in x that is not common with y. Information in x that is not common with y. Because given that y is y, you know the information in y. Whatever is the information that is common between x and y, that also you know. Entropy means the unknown things, information about unknown things. Right. Similarly, this part, see this one? This is information in y that is not common with x. The information in y, the exclusive information about y. You can think of this as exclusive information in x. Exclusive info about x. So this is exclusive information about y. It is h of y, given that you know what is transmitted. Given that x is transmitted, you know information in x. So what you don't know about y is only this part. If it is only h of y, this total circle. If it is h of y given x, So you don't want the common information with x because you know about information about x. The unknown information is only this much. So this is the Venn diagram, so using which we can easily understand the meaning of these entropies. So mutual entropy, the common information, joint entropy. Let's talk about joint entropy that we missed. H of x comma y. This total thing, these two circles together, we call it as joint entropy. Means all the information in x and y together. See this one, h of x plus h of y. When you are adding these two, you are adding this part, which is the common information, twice. So that's why we are subtracting it. It's as good as saying A union B. It's like A union B, information in A and B together. So when you are adding A union B, when you are doing A union B, we remove the common terms, right? In sets, when you are doing union, we remove the common terms, A plus B minus A intersection B. It is similar to that. One second, yeah. H of x comma, if you send it this side, I of x comma is mutual information. H of x plus h of y minus I of x comma, which is mutual information. I of x comma is like A intersection B. H of x comma y is like A union B. Okay, so that is the understanding. So that's it. So you can try this homework. So I'm giving you a homework question based on mutual entropy, conditional entropy, and joint entropy. This will take some time because in the exam they will not ask you to find all these entropies. They'll ask you only one question, which may not be taking too much of time. Which might take hardly 3 or 4 minutes, or if some calculation is involved, sometimes 5 minutes. But generally they'll try to minimize the time that is taken to solve a problem. Okay. For the practice sake, I have given you all the questions. So with the transition probability of 0.6, which means you can draw the pentasymetric channel, you can figure out the probabilities that are given. Once you figure out the probabilities, try to apply the basics that we have discussed in today's session, the formulas that we have derived. If you don't by heart the formulas, so the way we have derived it hardly took 4 or 5 minutes to derive. So you can quickly write, within half a minute you should be able to write the formula for joint or mutual or conditional entropy, right? So use that and find it. Okay, fine, that's it guys from my side for today's session. In tomorrow's session, what I'll do is, basically it was planned as a Menti session, but since less number of students are attending the classes, what we have planned is we'll do the most expected questions based on whatever topics I have discussed in the previous classes. So PCM, DPCM, delta modulation, mostly my focus will be on them. Whatever as the expected questions, what are the expected questions on those topics in the exam. So those questions I'll be discussing in tomorrow's session. So we'll meet again on in tomorrow's class at 8 p.m. Okay, and in today itself at 10 p.m. we're having one more session. I'm going to take a session along with 2 of my students. So who will guide you? So those students are MTech. They're almost done with their MTech. They're in their final semester. So they got placed in wonderful companies. One of them with the Texas Instruments and one of them with NVIDIA with huge packages, more than 30 lakhs you can say. So I'm going to take session with them. So they will guide you on how to prepare in masters for better placements, for better career and all those stuff. So don't miss out at 10 o'clock today. Okay, we'll meet in that session, right? That's it guys from my side. Thank you. Good night. Take care. Bye-bye.